We will start our exploration of trigonometry with right triangle trigonometry. Trigonometry is the measurement of triangles, so a lot of the problems that we will see is to solve a triangle. And solving a triangle means to find all the angles and the lengths of the sides of the triangle. We will start with right triangles. Right triangles have an angle that is 90 degrees, two other acute angles that are complementary. The two perpendicular sides are called legs of the triangle, and the longest side of the triangle that is opposite of the right angle is called the hypotenuse. And for one of the acute angles of a triangle, and you want to always mark it clearly so that we know which one you are talking about, let's call it theta. That is an angle that is less than 90 degrees. We identify the other three sides of the triangle as opposite of theta, adjacent to theta, and the hypotenuse of the triangle. And we have six trigonometric functions that we define. The sine of theta equals the length of the opposite over the length of the hypotenuse. The cosine of theta equals the length of the adjacent over the length of the hypotenuse. The tangent of theta equals the length of the opposite over the length of the adjacent. The cosecant of theta is the reciprocal of the sine. The secant of theta is the reciprocal of the cosine. And the cotangent of theta is the reciprocal of the tangent of theta. These formulas in our formula packet are in the middle of our second page, clearly marked as right triangle formulas. And again, you have to mark the angle theta clearly. For the right triangle, you also need to remember that you can apply the Pythagorean theorem, which means if you know two of the sides of the triangle, you can find the other side. In the first example, the angle theta is A, and the opposite is 12. The adjacent is 5, and we need to find the hypotenuse by doing the Pythagorean theorem. Hypotenuse squared will be 12 squared plus 5 squared. That's 169, and therefore the hypotenuse is equal to 13. So now we can find the six trigonometric functions of angle A. Try to pause the video and see if you can apply the formulas from your packet or from the notes. The sine of A is opposite over hypotenuse. The cosine of A is adjacent over hypotenuse. The tangent of A is opposite over adjacent. The cosecant of A is hypotenuse over opposite. The secant of A is hypotenuse over adjacent, and the cotangent of A is adjacent over opposite. For the next example, we can find the angle of interest is B. And for that triangle, we know the opposite to B, which is 4. We know the hypotenuse, which is 8, and we are looking to find the adjacent. So the adjacent squared will be the hypotenuse squared minus the opposite squared, which is 48. So the adjacent is going to be the square root of 48. I don't need plus or minus. The lengths must be positive. This is 48 is 3 times 16. The square root of 16 is 4, square root of 3. So the adjacent is 4 square root of 3. And the six trigonometric functions of beta will be the sine of beta or of angle B opposite over hypotenuse. I can simplify to 1/2. The cosine of B adjacent over hypotenuse. I can simplify to square root of 3 divided by 2. The tangent of B, opposite over adjacent. I can simplify to 1 over square root of 3, and I can rationalize denominators to convert it to square root of 3 divided by 3. The cosecant of B is hypotenuse over opposite, and I can simplify to 2. The secant of B is hypotenuse over adjacent, and that is 2 over the square root of 3, which I can rationalize to 2 square root of 3 over 3. And the cotangent of B is the adjacent over the opposite, which I can simplify to square root of 3. Here is an example of a question that asks us to solve a right triangle. So solving the right triangle means to find the angles at A, B, and C, and to find the little sides A, B, and C. It's customary to call a little a the side opposite to angle A, so that will be the side BC. Little b is the side opposite to angle B, so that will be the side AC. And little c is the side opposite to C, which is the side AB. So they are giving us little c to be 12, that's the hypotenuse. And they are giving us the angle at A to be 40 degrees. We know that C is the right angle from this drawing, therefore B is the complementary from A, so 90 minus 40 degrees, that will be 50 degrees. And the A, side A, will be the opposite to angle A, and side B will be the adjacent to angle A. So they have given me the hypotenuse. I'm going to look for trigonometric functions that include the angle and the hypotenuse. So the sine is one of them. It has the angle and the hypotenuse. And the cosine is another one. It has the adjacent and the hypotenuse and the angle, obviously. So if I know 2 of those measures, I know the angle and the hypotenuse, I can find the third one. So from the sine, I can find the opposite, and from the cosine, I can find the adjacent. So the sine of A, which is 40 degrees, will be the opposite, little a, over the hypotenuse, which is 12. If I multiply by 12, A equals 12 times the sine of 40 degrees. The cosine of 40 degrees will be the adjacent, which is B, over the hypotenuse, 12. Multiplied by 12, B is 12 times the cosine of 40 degrees. So the exact answers are that little a is 12 times the sine of 40 degrees, and little b is 12 times the cosine of 40 degrees. Now, if I want to estimate, and they are not telling me where to round, it is customary to round in one additional decimal digit beyond that the measures are given in the problem. So in this problem, the length of C is given as a whole number. Therefore, if I were to round and without instructions, I would round to the nearest 1 decimal place, the nearest 10th. Now, you want to make sure your calculator is in degree mode. My calculator usually defaults in radian mode. I have made sure it's not in radian, but it is in degree, so that when I use the sine of 40, it calculates the sine of 40 degrees and not the sine of 40 radians. If I do 12 times the sine of 40 degrees, the approximation to the nearest 10th will be approximately 7.7 for A. And B will be 12 times the cosine of 40 degrees. And that approximation to the nearest tenth will be 9.2. Now, these are irrational numbers. I don't really know the answers for the sine and the cosine of 40 degrees. So to check my work, I'm going to try the Pythagorean theorem, and I should get approximately the same answers. So if I do 7.7 squared plus 9.2 squared, I hope to get 144, which is 12 squared. And 143.9 is close enough. So I think I have done a good job here. Here is another triangle. They're asking us to solve it. So I'm gonna try to find the angle at A, at B, and at C. The side opposite to A, the side opposite to angle B, and the side opposite to angle C. A, B, and C here. They have given me the little b is 8. And they have given me the angle B to be 38 degrees. So this little b is the opposite. And A that they are asking me to find is the adjacent. And C that they are asking me to find is the hypotenuse. The angle at B is 38 degrees. I see from the drawing that C is the right angle, so 90 degrees. And A will be the complementary angle to B, so it will be 52 degrees. How did I find it? 90 minus 38. So that will be 52 degrees. And then I'm going to look for formulas in my formula packet that contain the angle theta and the opposite of theta. So the angle theta and the opposite of theta is in the sine. The angle theta and the opposite is in the tangent. From the sine, I can find the hypotenuse, and from the tangent, I can find the adjacent. So sine of B, which is 38 degrees, equals the opposite, which is 8, over the hypotenuse, which is C. I'm looking for C. So I'm going to multiply by C. C times the sine of 38 degrees will equal to 8. And I will divide by the sine of 38, both sides, to find C. So C, the exact answer will be 8 divided by the sine of 38. And again, I'm going to round to the nearest tenth because I don't have instructions and the measures here have been given to me with accuracy to the nearest whole number. So 8 divided by the sine of 38. Again, make sure we are in degree mode. 12.99, when I round it, it will be approximately 13.0. That is for C. To find the adjacent, I'm going to use the tangent. Tangent of the angle B equals the opposite, which is 8 over the adjacent, which is A. In a similar way, I'm going to solve for A. A times the tangent of 38 will equal to 8, and I will divide by the tangent of 38, and A will equal 8 divided by the tangent of 38 degrees. And I'm going to find that in the calculator with accuracy to the nearest tenth. 8 divided by the tangent of 38. And 2 with accuracy to the nearest tenth, 10.2 approximately. Now I'm going to check my work. I want 10.2 squared plus 8 squared to be approximately 13.0 squared, which is 169. And it is very close to 169 at 168.04. So one last problem for this video, and we will continue this section in a separate video. A 12-foot ladder leans against the building, so the angle between the ladder and the ground is 72 degrees. So if this is my building over here, the ladder, you see this right triangle, it's created between the building and the ladder. So the ladder is the hypotenuse of this right triangle. So the hypotenuse of this right triangle is the ladder, and it is 12 feet. And it leans against the building so that the angle between the ladder and the ground is 72 degrees. So this is the 72 degrees over here. Let's call this angle theta. And they are asking us how high will the ladder reach. So they are actually asking us for the length of the opposite. So the question is, how long is the opposite side to the angle theta? And I'm looking for a formula that contains theta, the opposite, and the hypotenuse. So I'm going to look here. The formula I'm looking for is the sine of theta. So sine of theta equals opposite divided by the hypotenuse. And now I'm going to fill in the values. The sine of the 72 degrees will equal to the opposite, which is I'm looking for. And the hypotenuse is 12 feet. So if I multiply by 12 feet, the opposite, which is the height that I'm looking for, will be 12 times the sine of 72 degrees, and the units will be feet. So the exact answer is 12 times the sine of 72 degrees, and the calculation to the nearest tenth, 12 times the sine of 72 degrees. 11.4 feet.